Again, 2.6. We are looking at families of functions. Okay, now, as we talk about looking at families of functions, you guys had this gold paper you used on your last quiz, yes? And on this gold paper, I said, okay, only look at the top portion, right? Because if you look at the bottom portion, you're probably going to be like, what is this stuff? I don't know what this is. We didn't need it yet, right? Okay, we're here today. Okay, so we're going to be talking about this section that you have on this gold paper that's transformation. Now, these gold papers, you're going to be able to use them on the test. When you're doing homework and stuff, you might want to have those gold papers beside you, or you might want to have your notes beside you. Okay, but we're going to talk about the different transformations. And these gold papers, we will come back to this list of transformations here. We will come back to a lot this year. Okay, we will constantly, there's several chapters that it seems like we keep coming back to them like once a chapter. So let's kind of go through, talk about what some of these are, and then we'll look at how they can be demonstrated. Now, first of all, that is supposed to say f of x right there. So f parentheses x. And we're just talking about all of our transformations. So we're talking about our translations, our reflections, and our stretches and compressions. Okay? Now, when we talk about translation, you guys remember what a translation is? What are you drawing back there, Levi?
You move like 90 degrees or something.
Not moving like in terms of turning. That's more of a rotation, I think.
Yeah.
But translation is just taking something and just moving it. Okay? In terms of, when we talk graphs, we'll talk about moving things 4 left, 5 right, 2 up, 3 down, whatever that might be. So, when you see a function, and there is a number added at the end. So when it says C, just think of C as some random number. Okay? So when there's a function and a number is added at the end, that number that's added at the end is going to tell my function, or my graph, how many units up to go. So what I need you to pay attention to here is, okay, if there's a number added in at the end, that's going to tell my graph how far to translate up, how far to shift up. Okay? Whereas, what if the number is subtracted at the end? If a number is subtracted at the end, that's going to tell my graph how far to move down. And to me, I don't know about you guys, to me that kind of makes sense. That a plus a number would take my graph up, minus a number would take the graph down. And that's how it works with vertical translations when you're going up and down. Now, when you look at the next set, you'll notice it says instead of the plus and minus C being at the end, the plus and minus C are in the parentheses. And so here, it's x plus C. Yes, Gabe, as you said, it's directly affecting x, right? And so when it's directly with the x, so whether it be in parentheses, in the absolute value bars, under the square root, directly with the x, then that's going to take it left or right. Now, are you catching this? What's it say x plus C does? It moves the graph left. Whereas, what does x minus C do? It moves the graph right. And so, again, maybe this is just me, but to me, that's the opposite of what I would expect, isn't it? Okay? And that's honestly kind of how I remember, is that when the number is added or subtracted directly from x, so it's in the parentheses with the x, we're going to shift the graph left or right, and I always say opposite the sign. You will hear me say that a lot throughout this year. Okay? So if the number is in the parentheses, it's going to be left or right, opposite the direction of the sign. Okay? Negatives. If you have a negative multiplied into an equation somewhere, it's going to take the graph and it's going to reflect it. Now, we have 2 different options. If the negative is out front of the graph, so if that negative is multiplied through by every term, then it's going to reflect the function in the x-axis. Which one's my x-axis?
Horizontal.
Horizontal. I see some arms being held out. So horizontal. So reflecting across the x-axis means it's going to go up or down. If instead the negative is directly on the x, that's going to reflect the function in the y-axis. So that means it's going to flip left or right over the vertical y-axis. Okay. And then, so there's translations, there's reflections. Our other piece here are vertical stretches and compressions. Meaning, okay, so first of all, A represents this. And you'll notice that A out front is multiplied. So if you have a constant, in other words, some number that is multiplied by the function, it is either vertical stretch or a vertical compression. So a vertical stretch means when I multiply that by that number, it's going to stretch my graph up. So it's going to pull it up, make it taller, kind of appears skinnier in the process. And that's a vertical stretch. Now, a vertical stretch happens if A is more than 1, bigger than 1. So if that number multiplying out front is bigger than 1, it's going to stretch my graph up. As opposed to the number out front if it is between 0 and 1. What kind of numbers are between 0 and 1? Decimals, fractions, right? Decimals and fractions less than 1. If my number is between 0 and 1, that's going to be, it's officially called a compression. You could call it a shrink if you prefer. I think my pre-cal book uses the word shrink. This book uses the word compression. But compressing. I don't know, I think like squashing it down. Does that make sense? That's, if we're shrinking something down or compressing it down vertically, it's going to get shorter. Now, in the process of getting shorter, it's probably going to appear wider. Okay? Trying to be polite here, Okay. So, a number multiplying is either a stretch or a compression, and the A value will tell you how it will go, whether it will be, a stretch or a compression. Okay, so those are the different type of transformations we're using. We're learning about them today. We're going to use them in tomorrow's lesson also, when we get to lesson 2.7. Okay? Now, all of these will always be based on some parent function, so some original function. So, in this case, we're just talking about f of x right now, but it's based on some original function. Okay? Okay, let's start looking at some of these examples. And as we start looking at some of these examples, we'll kind of talk our way through them. Now, I'm going to tell you, A, I'm going to go really deep into. I won't go as deep into the others, but A asks us, how are the functions y equals x and y equals x minus 2 related, and how are their graphs related? So thoughts on how the functions are related and how their graphs are related. Can you tell anything by just looking there? Do you know anything about what y equals x and y equals x minus 2 look like? No? You should.
Equations.
Equations of what? What's the shape of their graph? Not what I'm looking for, but what word did you just say?
Parallel.
Parallel. Parallel what? What?
Lines.
Lines.
Yeah.
Are these lines?
Yeah.
Isn't this y equals mx plus b? These are lines, right?
They look graphable.
Okay, they look graphable. That's good. We're going to graph them here in a moment. Now, I don't know if Gabe knows why he threw this word out, but how do we know these lines are parallel? How do we know? Kamara? The slope is the same. Remember that? That was on your quiz, right? If the slopes are the same, the lines are parallel. Are these lines going to be on top of each other? No. What's going to happen? Okay, so generally speaking, one's below the other. Specifically, how far below? 2 units below, yes? Okay, so let's look at all of this. Okay, let's put all this together, look at all what we've talked about. So, one way we're going to look at this is we're going to look at XY chart here. When I use an XY chart, I like to use some basic X values, -2 to +2. So -2, -1, 0, 1, and 2. If we are just talking about the first graph, y equals x. Can you fill in your y values? If x is -2, y is what? -2, because it said y equals x, doesn't it? If x is -1, y is -1. 0, 0, 1, 1, 2, 2. Because the equation was y equals x, my x's and y's are always the same. Okay, now for comparison's sake, let's make an XY table for the other equation, which is y equals x minus 2. Same x values. Fill them in. If I put in -2 in for x, what's -2 minus 2?
-4.
-4. If I put in -1, what's -1 minus 2? -3. 0 minus 2 is -2.
-1.
1 minus 2 is -1. 2 minus 2? 0. Okay. Notice I kept the x values the same, didn't I? How did my y values compare? If you start comparing these here, like the 2 to the 0, the 1 to the -1, so on and so forth, what's the connection?
-2.
Okay. Are each of my y values 2 less than the previous one? Okay. And again, that's based on these equations here, isn't it? So one thing I want you to be able to acknowledge is that I'm going to use the word output, right? Can I use the word output for y values? Okay. Each output of y equals x minus 2 is 2 less than the other one. So that's one thing I want you to be able to acknowledge. So I'm going to say each output of y equals x minus 2 is 2 less than the output of y equals x. And that kind of helps us talk about how are these functions related. They're related in that their outputs are just too different from each other. I also want to look at a graph of these two. I know we've already talked about what the graph's going to look like, right? But I want to actually look at the graph. X-axis, y-axis. I think I basically mark 2 out in each direction, except I need to be able to go, I think it's 4 down. Okay. When you're ready, let's graph the first set of ordered pairs. So we had -2, -2, which meant what? Two left and 2 down. -1, -1 is 1 left, 1 down. 0, 0. 1, 1. Right, 1 up, 1. 2, 2. Right, 2 up, 2. So that was my first set of XY values, right? Now, officially, I'm going to use my XY chart to do the second pair, but then we'll look at the connection. So -2, -4 says I'm going to go left 2, but this time 4 down. -1, -3, 1 left, 3 down. 0, -2, which is down 2. 1, -1, and 2, 0. Not the best drawn line there, but what's the connection between the graphs? It's the same line with what happening? It moved where? Where'd my graph move? Down 2, yes? Okay, now, I just used the word moved. Moved is okay. The official mathematic word, if we want to use our big fancy math words, is translated. Okay, so I'm going to say the graph is translated down to units. Okay. As I said, it's not that we can't say moved. Moved is okay. You'll sometimes hear me say the graph is shifted. But mathematically, officially, translate is the best word there. Here's what I'm going to tell you on a quiz or a test. Don't just tell me down 2. Give me a verb in there. I know it's not English class, but give me a verb in there. Translated down to, moved down to, shifted down to. Something to indicate what that down to is. Okay, so do you see all the connections here? As I said, I'm not digging in near as deep in the rest of this page before we go to the back. I'm just wanting you to get the connections there. Okay. So look at B. What is the graph of y equals x squared minus 1 translated up 5 units? So according to our chart up above, how do we translate something up 5 units? What do we do to the equation? Okay, if we're going to go up, you add c, right? What is my c value here? We're trying to go up 5, we're going to add 5. Okay, 5 is in place of the c. So what does this look like? My original equation was y equals x squared minus 1. What am I going to do to x squared minus 1? Add 5. All you need to do is clean that up for me. What is x squared minus 1 plus 5? Almost. Okay. Minus 1 plus 5 becomes plus 4. And so this equation can be rewritten as y equals x squared plus 4. Okay? We're not doing anything else other than that. I just wanted you guys, okay, make the connection. If it says up 5, that means we're going to add 5 to the equation. Okay, look at C. How are the functions y equals 2x and y equals 2x minus 3 related? How are their graphs related? Now, first of all, this question is a lot like question A. I'm just not going to do all the work this time. If you guys can handle that. So if this is like question A, and we have the graphs, or the equation, excuse me, y equals 2x and y equals 2x minus 3, how are they related? How are their graphs related? So we talk about how are they related. Okay, they're parallel. What else? Okay? It's going to go down 3. So when we look at the graph, it's going to be translated down 3, right? What about the output values? Since there's a minus 3, each output value is going to be
Minus
3 less. Okay? Those are the 2 pieces of information I'm going to write down. Okay? Those are the connections I want you making. First of all, I'm writing that each output value is 3 less. And then the key one to me is the fact that the graph, I'm going to use that big word, is translated down 3 units. Okay, so important to be able to make those connections. Each output value is 3 less, and the graph is translated down 3 units. D, what is the graph of y equals 3x translated up 2 units? How do we move a graph up 2? You add 2. So what does this equation look like if we add 2? That easy, folks. You add 2. You're adding 2 to the 3x, so y equals 3x plus 2. Thank you. And what is 3x plus 2? 3x plus 2? Can we add 3x and 2?
No.
No, not like terms. That's my trick question I like to throw out. I do that a lot.
I'm just leaving it.
Okay. And get what you need there. Now let's look at the back side. That front side, that was really just dissecting vertical translations. We're going to do some various other things here. No. We're going to talk about horizontal translations. Now, horizontal means we're talking left or right. So given f of x, whose graph is drawn, find the values on a chart for a translation right 5 units. Okay.
Can you just scale it by 2?
Not if we're translating it right 5. That wouldn't be the same. Or at least depending on what you're meaning. I don't think so. Okay. My first suggestion, it says to find a value of values on the chart for a translation right 5. My suggestion is we start to make sure we're all on the same page here. Let's write down what our current values are of these points. What is that first point there? What is that first ordered pair? 1, 1, yes? I know it's not the best drawn graph, but you can do this. What's the next point over? I believe it's right 2 up 2, so 2, 2. What is that peak up there? I think it's 3, 4. What's the next one? 4, 1. And there's one more, which is at 5, 1. Okay, didn't leave myself quite enough room here. Now, those are the given pieces. Okay? The question specifically says now to find the value for a translation right 5. Any thoughts on what my chart is going to look like after I move these points right 5?
You just gotta
He says add 5 to all the x values. Do you like that? Okay. And here, if you're questioning, if you're saying, I don't know if I like it or not, take this point. What do I do with this point? Move it. 1, 2, 3, 4, 5. Where would that new point be? 6, 1. Does that make sense when Levi says add 5 to the x value? Yeah. Okay, now, you have a choice. You can redraw the whole picture, right, and get your ordered pairs that way. Or what's the shortcut? Can we use our XY chart and just translate it over? I shouldn't use the word translate, but move it over. So what does 2, 2 become?
2, 7.
Not 2, 7. 7, 2. And this is because we are trying to move this graph where? Right 5, which basically means we're taking each of the x values and adding 5. What does 3, 4 become? 8, 4 if you add 5. 4, 1 becomes 9, 1. And 5, 1 becomes 10, 1. Okay? So, all I want you to really get out of this is, okay, realize when you move the graph right 5, or left or right, what's the only thing changing? It's just the x values, isn't it? Okay? Now, I know in my morning class there are some people saying, well, wouldn't we be subtracting 5? Because when you look at the equation, it talks about doing the opposite. But, okay, if we were asked to do something or write something, x minus 5 in parentheses, sorry, you can't see what I wrote there, that would represent the whole right 5. But since they physically told us to move it right 5, we're going to do just that. Okay, we're going to move it right 5. Okay, questions there? Okay, moving right along then. Reflections. Okay, so read the problem and then there's some information about reflections on the front. Let g of x be the reflection of f of x equals 3x plus 3 in the y-axis. What is a function rule for g of x? Okay, so what's it want us to use? It says let g of x. So when I get done, my answer is going to be g of x. And what is it going to be? A reflection how? In the y-axis. Okay, flip back to the front side. What do your notes say about a reflection in the y-axis? A reflection in the y-axis is f of negative x. And what that means, okay, my original function is f of x. F of negative x, every place I see an x, I'm going to replace it with negative x. So instead of 3 times x plus 3, I'm going to say 3 times negative x plus 3. Because it said f of negative x, I took x and I replaced it with negative x. What is 3 times negative x? Negative 3x. And then I have negative 3x plus 3. And officially it said, what is a function rule? What do I mean function rule? What am I asking you to write? Some of you guys missed this on the last quiz. If I'm asking you for a function rule, I'm asking you to write an equation. Okay? when it asked me to write an equation, it told me to use what? G of x. And we put negative in, what did we get? Yeah. Okay, well, so it said let G of x be the reflection of f of x. So once we do the reflection, which means we do f of negative x, we put the negative in for x, negative x in for x, then that is the reflection, and they told us to call it G of x. Okay. The key there is to be able to find the negative 3x plus 3. Okay, so in order to get a reflection in the y-axis, it said, the direction said f of negative x. That's what's on our chart, right? Questions? Okay, let's try the next one. This time, what's it say? This time it says to use h of x. And this time it's a reflection in the x-axis. What's our chart say about a reflection in the x-axis?
Negative f.
It says to use negative f of x. And so if we're using negative f of x, that means we're going to take negative. I like to think of it as multiplying the whole equation by negative, is what I like to think. So I'm going to take negative and distribute it to both 3x plus 3. Or, if I'm multiplying by negative, what's going to happen to every sign? It's going to flip, right? It's going to change. So positives become negatives. Negatives become positives. So positive 3x becomes negative 3x plus 3 becomes minus 3. And so notice the difference this time, both signs changed. Okay? So we end up with h of x equals negative 3x minus 3. Okay? So reflection, just watch and see, okay, x-axis or y-axis, how do you change the negatives? Okay, I want to get through this stretching and compressing part, and then you should be set to go here. We're going to see. The homework's still due tomorrow. We're not going to necessarily work on it tomorrow, but we may do some follow-up questions or finish a little bit of the notes. I'm not sure yet. Okay. Okay, look at example 4. Table below represents a function, f of x. And it's asking what are the corresponding values. And for A, it says g of x if g of x equals 3 times f of x. Okay, look back in your chart and see. And it even gives you a hint here, right? Stretching and compressing a function. If it says 3f of x, what does that represent? A stretch, yes? Because, how do we know it's a stretch? 3 is what? Bigger than 1. Did you flip back and look at your chart? Okay, if you flip back and you look at that chart, get my papers to part there. But right there, if it's a times f of x, so it's a number times f of x, it's a stretch if a is bigger than 1. And that's what we have here. So now, this is, lost on my screen here. So we're going to be doing a stretch. Now, here's the deal. We don't really have to know that it's a stretch for what we're doing here. It says to find g of x, but in order to find g of x, we're going to do 3 times f of x. And it wants us to write the corresponding values. So in this area here, I'm going to write a new xy chart. But before I do that, what is it I'm going to multiply by 3, you think? if we're trying to do a stretch, and it says 3 times f of x, if it says 3 times f of x, what are we multiplying? We're multiplying our f of x values, which, let me back up. What is f of x another name for? That's our y values, right? F of x is another name for y. So if we're doing 3 times f of x, it's just doing 3 times our y values. This is a vertical stretch. We're not touching the x values. We're only messing with the y values, the f of x values. So if I do 3 times f of x, well, my first f of x value is 2, right? 2 times 3 is 6. 2 times 3 again is 6. Negative 3 times 3? Negative 9. 1 times 3? 3. Negative 2 times 3? Negative 6. Those right there, what I just put off on the right side, are the f of x values. Those are my new f of x values. Those are what we're going to call g of x. Now, I am much more a vertical chart person, but the space here is not set up for a vertical chart. It's set up for a horizontal chart. So I'm going to set up a chart where x's are on top and g of x's are on bottom. The original ordered pair was 5, 2. I multiplied by 3, and so instead of 5, 2, now I'm going to write it as 5, 6. My next ordered pair was negative 1, 2. Now it's going to be negative 1, 6. Instead of 6, negative 3, 6, negative 9. Instead of negative 5, 1, it's negative 5, 3. Instead of 4, negative 2, it's 4, negative 6. Okay. Guys, all of that to say, for a stretch or compression, you only multiply the y values. Okay? Now, let's do B real quick before we run out of time. B says we're going to call them h of x. And what does it say h of x is? 1/3 f of x. What does that 1/3 mean? Yeah, this is going to be the opposite of a stretch. This is going to be a compression. If you prefer to use the word shrink, I can handle the word shrink. Okay? Now, we're doing 1/3 f of x, aren't we? I'm going to use this. I have a little bit of space over to my right here that I can still use for the math. Then we'll come back and put it in the chart. 1/3 f of x. Okay. So, I say multiplying by 1/3. Lily says, so dividing it by 3? Yes, that works. If this value is 2 here, I would say 2 times 1/3. But what is 2 as a fraction? It's 2 over 1. And 2 over 1 times 1 over 3 is going to be 2/3. Okay, or so, as she said, 2 divided by 3, 2/3. Okay. We have another 2, so what's 2 times 1/3 again? 2/3. Then we have a negative 3. Negative 3 times 1/3. You can think negative 3 over 1. So it becomes negative 3 over 3, which is negative 1. I've got a 1. What's 1 times 1/3? Oh no, 1/3. And negative 2 times 1/3 is going to be negative 2/3. Okay, listen. I'm going to finish filling in my chart. Listen, please. I'm going to finish filling in my chart. Your job is to look at the homework and do the homework for lesson 2.6. Make sure you come with it started. We can talk about questions if we need to.
Mr. Wilson's room.
Okay?
Ellie Taylor and Anastasia Solis, please report to Mr. Wilson's room.
So x and h of x. It was 5/2. Now it's going to be 5, 2/3. Was -1, 2. Now it's going to be -1, 2/3. It was 6, -3. 6, -1. Was -5, 1. -5, 1/3. And it was 4, -2. 4, -2/3. Is your new chart of values. We will go over some of these bottom examples tomorrow if we need to, or we may just use homework examples. We will see how things go. Your homework, to make sure you get finished up, is lesson 2.6 in Math Excel.
White binder in here with an economy book. No.
I have not.